Alright, so to help you keep the different characteristics of the different shapes organized and clear in your mind, I want to go through this mind map. We're going to talk about the different angles, characteristics of the different angles, the different sides, and the diagonals. Those are the three main parts of the shape that we're going to look at. So we're going to start over here with the kite, and we're going to talk about things that are true about the sides. We're going to talk about things that are true about the angles, and then things that are true about the diagonals. The first characteristic of a kite is that two sets of adjacent sides are congruent, but they're not congruent to each other. So when I say two sets, I'm talking about that's one set of adjacent sides, and then the top part of the kite, that's another set. So there are two sets of adjacent sides that are congruent, but then those two sets are not congruent to each other. So we're saying that this is congruent to this. So there's one set of congruent adjacent sides, and then this is congruent to this side over here. So there's my second set of adjacent sides, and they are congruent sets but not to each other. So these are not congruent to these is what that means. The second thing that's true about a kite is that there is only one pair of opposite angles that are congruent. So that means that the angles that are formed by the two different adjacent sides coming together, those are what going to be congruent. So that means that this angle is going to be congruent to this angle over here. So only one pair of opposite angles are congruent, and those happen to be the angles where the two different sets of sides come together. The next characteristic of a kite is that the diagonals are perpendicular. So the diagonals go from opposite corners, and when they meet, they form right angles. So each of these angles right here, each one of these angles is a right angle. And the last thing that's true about kites is that one of the diagonals is bisected. And when we're thinking about the diagonal that is bisected, it's the one that comes from the congruent angles. So this segment will be congruent to this segment. And the reason that we know that is because if this is a right angle, and this is the hypotenuse of this right angle, and this is the hypotenuse of this right angle, and these two sides are congruent, this side is also going to be congruent because it's going to be the reflexive property. This is the long side of this right angle. It's also the long side of this right angle. So by definition, these two, hypotenuse leg says that these two have to be congruent. So one of the diagonals is bisected, and it's the one that goes from the opposite congruent angles. So those are the characteristics that we can assume are true whenever we're told a shape is a kite. So moving on to a trapezoid. One of the things that we know about a trapezoid is it has only one set of parallel sides, and that would be the two bases. We refer to both of these as the bases. So the top base and the bottom base, or the shorter base and the longer base, are going to be parallel to each other. The second thing that's true about a trapezoid is that the base angles on each leg are supplementary. So we need a little bit of terminology here. These are called the bases. So these sides that angle towards each other are called the legs. So the base angles on each leg. So if I'm talking about this leg, we're talking about this angle right here is going to be supplementary to this angle right here. So those two angles, when I add them together, are going to equal 180. That is also going to be true of this angle and this angle. Those are also going to be supplementary angles. Now, unless it's a specific kind of trapezoid, these two angles are not necessarily congruent, and these two angles are not necessarily congruent. That's why I drew 3 and 4 lines here. But the base angles of each leg will always be supplementary. Now, I mentioned a special kind of trapezoid, and that is an isosceles trapezoid. So when we're talking about an isosceles trapezoid, we know isosceles triangle means two legs are congruent. Well, that's the same with an isosceles trapezoid. So in an isosceles trapezoid, we're still going to have the two sets of parallel sides, only now my legs are going to be congruent. So if my legs are congruent, that also means that these base angles will be congruent. And it's still true that the base angles on each leg are supplementary. So if this is congruent to this, and this is supplementary to this, then that also means I can conclude that these angles are also going to be congruent. And that's only true in an isosceles trapezoid. And all quadrilaterals, so a quadrilateral is a four-sided figure, the angles, the interior angles of a quadrilateral will always be 360 degrees. So just like all the interior angles of a triangle added up to 180, all the interior angles of a quadrilateral will add up to 360. All right, so we've talked about kites and trapezoids, which are their own type of quadrilateral, and now we're going to talk about parallelograms. And parallelograms are a special kind of quadrilateral because we can categorize that parallelogram down to more specific things. So we also have a rhombus and a rectangle, which are both types of parallelograms. So they have all the characteristics of a parallelogram plus their own characteristics. And then we have a square. And so a square, if you look at the way this is organized, is still a parallelogram, but it's also a rhombus and it's a rectangle. So it has all the characteristics of a parallelogram, all the characteristics of a rhombus, and a rectangle, and that's what makes up a square. So we're going to look specifically at a parallelogram first, and then we're going to look at those specific types of parallelograms. So let's start with a parallelogram. The first thing that's true about a parallelogram is that both pairs of opposite sides are parallel to each other, hence the parallelogram. So that means that this side is parallel to this side, and this side is parallel to this side. So both pairs of opposite sides are parallel. The second thing that's true about a parallelogram is that not only are the opposite sides parallel, but the opposite sides are also going to be congruent to each other. So that means that this side is congruent to this side right here. It also means that this side is going to be congruent to this side. So both pairs of opposite sides are parallel and congruent. The next thing that's true about a parallelogram is that the opposite sides are congruent, but also the opposite angles are congruent. So this angle right here is going to be congruent to this angle right here. And this angle right here will be congruent to this angle right here because those are opposite angles. The angles are also going to be supplementary, so all consecutive angles, so meaning angles that are adjacent or not adjacent, that are next to each other. So I'm talking about A and B. So A and B will add up to 180. B and C will add up to 180. C and D will add up to 180, and D and A will add up to 180. So all consecutive angles, meaning next to each other, are going to be supplementary. So there you can see all of the angle combinations that will give me 180 degrees. And the last thing that's true about a parallelogram is that the diagonals bisect each other. So the diagonals are not necessarily congruent because if you look, because of these angled sides, this diagonal is going to be a lot longer than this diagonal. So the diagonals aren't congruent. However, the point where they meet is going to be the midpoint of each segment. So that means that when I draw in my two diagonals, this to the point of intersection and this to the point of intersection are going to be congruent. And then on this diagonal, from B to the point of intersection and D to the point of intersection, those are going to be congruent. Now notice that they're not necessarily congruent to each other, because this has 3 markers and this has 3 markers. And this has 4 markers and this 4 markers, because remember, this segment is a lot longer than this segment. But they are going to have a midpoint, meaning this segment is going to be congruent to the other part of its diagonal. So those are all the truths about a parallelogram. So as we move into a rhombus and a rectangle, remember that those shapes are also going to have these things plus a couple more characteristics. So a rectangle is going to have opposite sides that are parallel and congruent. It's also going to have, excuse me, opposite angles that are going to be congruent to each other. And the diagonals are going to bisect each other. But it's also, as you know, going to have right angles. So we're all familiar with the fact that a rectangle has 4 right angles. And if you notice, we said a quadrilateral has 360 degrees, all of its interior angles. Well, 90 times 4 is that 360 degrees. So basically a rectangle is a parallelogram that's just been stood up straight. So if I took this parallelogram and I stood this side up straight and stood this side up straight, it's going to be that parallelogram that's been shifted to a vertical standing, which is why it has those 4 right angles. So another thing that's specific to a rectangle, which if you think about, the reason that my diagonals of a parallelogram are not congruent is because this distance from B to D is a lot longer than the distance from A to C. But when I take this line and I rotate it and stand it upright, that's going to put the distance from B to D and the distance from A to C the same. So the next thing that is true about a rectangle is that because I stand it up and give it those right angles, the distance from A to C is going to be the same as the distance from B to D. So it's still true that the diagonals bisect each other, but now those diagonals are going to be congruent. So that means that each piece of the diagonal is going to be congruent to all the other pieces. So let's look at what that looks like. So because I stood those right angles up, BD is going to be congruent to AC. And we talked about parallelograms, the diagonals bisect each other. So AE is congruent to CE. But since AC and BD are also congruent, that means that they're also going to be congruent to the 2 pieces there. So if I think about if this is 10, that makes this 5 and 5. And since diagonals are congruent in a rectangle, this will also be 10, which makes these 5 and 5. So in a rectangle, each of those segments are going to be congruent to each other. So we move over to a rhombus. And a rhombus, if you notice, is shaped like a parallelogram. But it's a parallelogram where these sides have been compressed in to where all sides are congruent. So that means that this side, this side, this side, and this side are all going to have the same measures. So remember, it's a parallelogram that's been squeezed together to where all 4 sides are congruent. So another thing that's true about a rhombus is that the diagonals are perpendicular. And I want you to think about, when you look up here at the parallelogram, you can see that these diagonals meet at 2 very acute angles and 2 very obtuse angles. So as I take this side and I move it inward, it's going to make those, the angles that the diagonals meet at, it's going to make them kind of square up. And so what happens is when I end up with a shape that has 4 congruent sides, that's taken those diagonals that were once very skinny and compressed, and it's put them perpendicular to each other. So don't be confused. It still has that shape of a parallelogram. So this is still going to be longer than this. The diagonals are not congruent. They're only congruent when there's a right angle. So when the sides are standing straight up and meeting at a right angle, that's when they're going to be congruent. This is still going to be a little bit longer than this one. However, they do make a right angle because those sides are equal. So when all sides are congruent, then those diagonals are going to be perpendicular. They're going to form 4 right angles. And so that is something to keep in mind about a rhombus, and I want you to keep that straight in your head. The right angle makes the diagonals congruent. The equal sides make the diagonals perpendicular. And the last thing that's true about a rhombus, which you'll have to add this one in, I'm not sure why it wasn't on there, but the diagonals bisect the opposite angles. So let's remember back to a parallelogram. Those opposite angles are congruent to each other. So this angle is going to be congruent to this angle, and then this angle is going to be congruent to this angle. Now, these angles are supplementary. They're not congruent to each other. The only time they're congruent to each other is in that rectangle when I have those right angles, where all the angles are going to be congruent. But the diagonal is going to bisect those congruent angles. So we think about if this angle is congruent to this angle, and the diagonal is bisecting, then really what's happening is it's bisecting this angle. So if this angle were 50 degrees, then it bisects it. Each of these would be 25. But because these angles are congruent to these angles, I can also say that these angles are being bisected as well. And like I said, since they're congruent, because it's a parallelogram and both pair of opposite angles are congruent, all four of these angles will be congruent to each other. Likewise, these opposite angles are congruent, but because the diagonals bisect those opposite angles, so these are also going to be congruent to each other. So this is bisected, so those two are congruent. But since this whole angle is congruent to this angle, when I bisect it over here, it's still going to be the same as these. Now remember, it's not equal to these because I can see that this is an acute angle and this is an obtuse angle. They're still going to be supplementary, the large angle and this angle, but those diagonals will cut those angles in half. So we have a parallelogram, we have a rhombus, and we have a rectangle. And all of those characteristics of those three shapes are true of a square. So a square is a parallelogram, so it has all of these things. It is a rhombus, so it also has these characteristics, and it's a rectangle, so it also has these characteristics. So it still has opposite sides that are parallel and opposite sides that are congruent. However, it's going to share that characteristic with a rhombus that not only are the opposite sides congruent, but they're all going to be congruent to each other. So a square is a rhombus that's just been set up straight. So all four sides are congruent. It still has both pairs of opposite angles that are congruent. So this angle will be congruent to this angle, and this angle will be congruent to this angle. But like a rectangle, what's special about those is it's been set up straight, so they are all right angles. So I've got a square is a parallelogram that's been set up straight, but that has equal sides. All consecutive angles are supplementary, which 90 plus 90 is 180, 90 plus 90 is 180, and so on and so forth. The diagonals are also going to bisect each other. So this is going to be the midpoint, where they meet is going to be the midpoint of that diagonal. But because of those right angles, if you remember we talked about with a rectangle, because of those right angles, these diagonals are not only going to be bisected when they meet, but they're going to be congruent to each other. So remember, when I have those 90-degree angles that set the shape upright, that now makes this distance congruent to this distance. So not only do they bisect each other, but they're congruent. And the last thing is that the diagonals are also going to be perpendicular where the square meets. So where those diagonals meet, because all four sides are congruent in the square, they're going to meet at a right angle. So the equal sides make the diagonals perpendicular, and the right angles make the diagonals congruent. So those are all the characteristics of the types of quadrilaterals that we're going to talk about in this module.